Hey everyone, and welcome back for another deep dive. Today we're going where no deep dives has gone before.
Well, kinda.
Yeah.
We're talking about planetary defense. I mean, how cool is that? Like, we're actually at a point where we can try to protect our planet from asteroids.
Yeah, it's straight out of science fiction.
Right. But, like, it's real science now. So, remember a few months back, all those headlines about NASA smashing a spacecraft into an
Oh
asteroid?
yeah, definitely the DART mission.
Yeah, DART for double asteroid redirection test. Anyway, they were trying to see if they could, actually knock an asteroid off course, like a test run for saving the planet.
It's pretty mind-blowing when you think about it.
It really is. And get this, it actually worked. They changed the asteroid's trajectory.
Yeah, by a significant amount too.
Yeah.
Way more than they initially expected.
So, like, we might actually be able to stop a killer asteroid from, wiping us out. We're going to break down exactly how they did it, what it means for the future, and why it's such a huge deal, not just for science, but for, like, humanity. Absolutely. It's a real game changer.
So DART targeted this small asteroid called Dimorphos. It was orbiting a larger asteroid named Didymos. They weren't like on a collision course with Earth or anything. It was all very carefully planned.
Right. Like, it was the perfect test subject. You wouldn't want to try this out on something that was actually a threat.
Exactly. So no need to panic yet. So the spacecraft they used was, I read, about the size of a vending machine, which just seems kind of crazy.
Yeah, like you're going to take out an asteroid with something the size of, a soda machine.
Yeah, right. So did they just like ram it into the asteroid at full speed?
Well, yeah, kind
True.
of. The technique is called a kinetic impactor. Imagine like a cosmic billiards game, you're trying to use one ball to change the path of another.
Okay, so not like blowing it up Hollywood style.
No, not at all. More like nudging it. Just enough to change its course over time. And it's all about those tiny nudges having a big impact, literally over like astronomical distances.
That makes sense.
Mhm.
And so their initial goal was to change Dimorphos's orbit by, I think, like just over a minute? 73 seconds, something like that?
73 seconds, yep. That was their like minimum benchmark for success. And well, they blew that out of the water.
Oh, really? How much did they change it by?
33 minutes.
Whoa, 33 minutes. That's like a whole lunch break.
Exactly. They totally exceeded expectations. It just shows you how precise they were and like the power of this technique.
I bet the scientists were freaking out when they got that data.
Oh, absolutely. Celebrations all around. They were calling it what was it? A watershed moment for planetary defense. And they're not wrong.
Right. 'Cause, like, even a small change like that could mean the difference between, an asteroid hitting Earth and missing us completely.
Totally. It's all about early intervention. The earlier you can make a course correction, the less you need to change it overall.
Right. And that kind of highlights another crucial aspect of all this, right? Like early detection. You got to know what's coming before you can do anything about it.
Exactly. And like you can't deflect what you can't detect, right? So NASA's got this ongoing mission to, you know, map and track near Earth asteroids, basically. Asteroids whose orbits bring them, relatively close to Earth.
So how many of those are they keeping tabs on?
Over 27,000 as of right now. But thankfully, most of them don't pose any real threat.
Okay, that's a relief.
Yeah.
So few, but still, good to know we have at least like a fighting chance now, thanks to missions like DART.
Yeah, for sure. And DART wasn't just a solo NASA mission, by the way. The European Space Agency is sending up a follow-up mission in 2024 called HERO.
What's that going to do?
It's going to study the crater DART created, get more data about how the impact, actually affected the asteroid. It's really cool. Like international collaboration and action, all for the sake of planetary defense.
Yeah, it seems like this whole thing has really caught the world's attention. Yeah. Like even Elon Musk was tweeting about it.
Right. Like this is something that affects everyone, right? Doesn't matter what your goals are in space. We all have a stake in protecting our planet.
For sure. And beyond the whole saving the world aspect, this mission has been a huge boost for science and technology.
Yeah.
Like it spurred so much innovation and development, created jobs, all sorts of things.
Definitely. And you can't forget the inspiration factor, It's like we can actually do this. We can protect ourselves from, these cosmic threats. It's pretty powerful stuff.
Yeah, it's
Yeah.
pretty amazing. And imagine how inspiring it is for kids, right?
Yeah.
Like they're growing up in a world where this is actually possible.
Exactly. It shows them what we can achieve when we, put our minds to it and work together.
Okay, so bottom line, humanity has taken a huge step toward protecting itself from, asteroid apocalypse.
Yeah, we're not just sitting ducks anymore.
It's not just science fiction anymore.
Nope, it's reality.
Which, okay, that's pretty amazing, but it also makes you wonder, right? Like, what other threats are out there lurking in the vastness of space?
Right. And are we prepared for those?
Yeah. Like, what's next for planetary defense?
It's definitely something to think about, isn't it?
Food for thought, everyone. And with that, we'll wrap up this deep dive. Thanks for listening.
See you next time.